When a dimensional constraint is defined, it's displayed in the parameters manager. Now there you can change the value or you can add what's called a formula. Well, let's open up our example file. Look at the mechanical example-imperial.dwg file. Now here we have a fully constrained object. It has all the geometric constraints that you could possibly have. I'm going to turn those off. And it also has dimensional constraints. Now, as you zoom in and out, the text for those constraints will stay the same height and relative to the rest of your screen. So it's going to kind of block your view. So that's why a lot of times you'll have these constraints hidden. But if you open up your parameters manager, this gives you a tablet and it will show you all of the different dimensional constraints that you have. Now, dimensional constraints can work in a couple of different ways. They can work very straight up in that your value is exactly what it's measuring, that distance or that radius, that size. But if you look at some of these, you'll see the bolt hole's top left as an example. The parameter here says bolt hole. Well, bolt hole is this dimensional constraint. Its value is 1 inch, and it tells you what type it is right here. It's a diameter. That tells you that your bolt hole left is going to be the same value as the bolt hole dimensional constraint. So you can do that. You can really program your line work this way. And that's how we do that. So our bolt hole diameter is controlling the diameter of this circle. And we have this equals geometric constraint to make sure that it is equal to this hole. Same with this hole. Same with all of these. That way, when you change one, you change all of them because they're equal. And so this bolt hole, which equals 1 inch, that's right here, is also constrained to up here to this dimension. We have two different dimensional constraints, bolt hole top left, bolt hole left half. Now you've got to get creative with these names so you can keep track of them. And so that's one thing you have to keep in mind. I'm going to hide the properties palette here so we can see the screen a little better. So this is kind of complex here, but what this drawing does is that when I change the circle diameter of the bolt hole, it will change the cross-sectional view. So if I change this expression to 2, it changes its value to 2, and you saw here bolt hole and bolt hole half changed as well. That made this hole bigger, did the same over here as well. So again, when your dimensional constraints are created, they're defined or displayed here in the parameters manager. And here you can change the value or you can add a formula. Now this file, as you can see, has several in it. And in the name column, it has the name of the parameter. The expression column is the expression or its formula. And that formula can be very simple as just being a regular number or a value. And that's what the case is for the bolt hole. Now, that actual number or that expression or that formula can be the name of another dimensional constraint. And that's what we've done here. Or you can combine that name with a formula. Here's bolt hole divided by the value of the number 2. And so it's an algebraic expression. Here in this case, we have the shaft ID. That's the inner diameter of the shaft. That's this guy right here. And it's set at 3. Now we have the shaft side ID, which comes over here. And that just values the shaft ID. Shaft ID divided by 2, and so on and so forth. We do that to control all of the lines and to do the work that we want it to do. So let's start a blank file. Use the acad.dwt template file. I'm going to close that for now. And let's draw a rectangular shape. Let's make it 5 units by 5 units. Type in the number 5, hit tab, number 5 again, press enter. And this has been fully constrained. And if you're not sure if it is or not, hit the auto constrain, select everything, press enter, and you can see it added something into it. I'm going to turn off the infer constraints for now. Let's draw a circle from the center of the block. And I'm going to get it diameter of 5 units. So it fits perfectly inside here. I'm going to auto constrain this to see if anything changes. And we have some tangents there now. I'm going to apply some dimensional constraints now to each leg. Just going to go linear. From there to there to D1. And we're going to do the same thing here to here. And it can't create this because it's going to over constrain it. So what I'm going to do is I'm going to delete all of the constraints because I've over constrained it. And you may find out that happens from time to time. There we go. And these are now working. If I turn this on through the Parametrics manager, you can see here I have D1. and I have D2. And with these shown, as I select them, it highlights them and lets you know where they're at. So now if I make D2 in the expression, I'm going to call it D1 divided by 2. It's going to make it half of the value of D1. It moved that line up. Now I'm going to add a radius. I'm going to add it to this circle. You can put this spot anywhere else you want. That spot can go anywhere. And now I have radius. The value is 2.5. I'm also going to change that to D1 divided by 2. So now if I change D1's value, let's say to 8, everything gets a little bigger. Now, because we don't have it properly geometrically constrained, or we haven't added more dimensional constraints at all, that kind of goes crazy. Because now, if I change it back to 5, luckily it goes back to the way it belongs. So you can also use filters. I can group filters in a lot of different ways. I can isolate some different groups in the filter, and I can go to these in case I want to. So what I can do is just kind of click and drag the different filters in here. And I can right click on that group and say isolate it. That way I work with only my box dimensions. So if I create a new filter group, I can call it whatever I want. I put the radius in here. Now I can show it, or I can isolate it. So now I only have to work with my circle based or my radius based or however it is I wanted to define that group. So your filters will help you out because as you can see in this example file here, there are a lot of different expressions that we can use and get to. That can make it very difficult to work in. So when you work with these, organize them by filters, by groups like that. Give them names, make sure they are relevant to the geometry or to the type of constraints you're trying to use to make it easier on yourself to work in. But you can remember to use your dimensional constraints to define something, and then you can use other constraints to make something equal to that or some fraction of it or relate to it in some other way. So let's say you have one hole and you need a second hole, but you need that second hole to always be 1 inch bigger so that you would just say bolt hole equals whatever value that circle is, and then bolt hole 2 equals bolt hole plus 1. You can do that. So your dimensional constraints can really help you organize your line work and keep everything relative to each other so that making changes to a design are fast, complete, and accurate.